Hi, in this video we'll be discussing important information on Martin drive and power systems. In order to have the effects system's components operate, there needs to be a way to drive the functions of those effects and power the parts that drive them. This diagram shows a three-dimensional exploded view of the Mac Viper. The printed circuit boards, or PCBs, contain sensors, which are used throughout the fixture, along with the motor driver, also known as the MDLP or motor driver low power, the main board, and the controller board, or CPU. Working units of the Mac Viper like the CMY mixing module, effects module, and focus module have the same PCB but are programmed differently. Stepper motors are used to drive all moving parts within a fixture. The igniter is designed to provide the initial large strike the lamp needs to start, and the ballast is designed to keep a steady flow of voltage to the lamp. The early Martin fixtures contained one main board placed in the base of the fixture that carried all components. This means a lot of wires ran from the base of the product through the yoke and then to the head. With clusters of wires located in moving parts of the fixture, this caused the wires to become brittle and break in those areas of movement. With the introduction of the Mac 3, a new system that consisted of driver boards was developed to reduce the amount of wires running from the base to the head. This system gave each module its own driver board, allowing the data to be distributed over a set of wires. This board can be seen at the top corner of the image on this slide. The bottom right corner of the image shows the driver board that is used in each module to drive each of the components, as well as store calibrations for each module. Lastly, the two PCBs on the left side of the image are two different types of sensors. Fans are used to transport excess heat out of the fixture to prevent overheating or eventual component failure. There are three types of fans designated by their wire amounts, but only two are relevant for current Martin fixtures. The 3-wire fan provides power, ground, and feedback, while the 4-wire fan provides power, ground, feedback, and pulse width modulated signal, or PWM. With PWM, the speed of the fan can be monitored, and the fan speed can be controlled depending on what is required. The fan can respond to different temperatures rather than running constantly like a computer CPU fan where the temperature can fluctuate. Martin's utilization of stepper motors within the product line gives many of the fixtures the ability to have precise control over their position. The stepper motors are used to drive the effects by making precise incremental movements of a fixture. These movements are achieved in half steps or increments of 9/10 of a degree. When even greater accuracy is required, these motors can be driven in microsteps to increments of 28/1000ths of a degree. In the Mac Viper, the pan and tilt are extremely precise because it uses what is known as an absolute encoder. This encoder sits on top of the polarity of the axle and monitors its microsteps, rather than using a normal sensor that looks for a passing magnet. This is useful when producing a beam at its maximum distance, where one very small movement can make a big difference in how much the projection moves, as opposed to controlling a fixture with a projection target not very far away. So the fine adjustment is not needed because the step moves it enough. The finer the movement can be created, the more accurate it will be. As previously mentioned, the igniter is designed to provide the initial large strike the lamp needs to start, and the ballast is designed to keep a steady flow of voltage to the lamp. In many countries, fluctuating mains are not so problematic, but in others, fluctuations can be extremely intense. Because of this, the ballast used in Martin fixtures are specified with very high standards and capable of managing these conditions in most cases. However, there are still limitations, which is why it is not recommended that fixtures be powered by unstable power sources. The igniter generates a lot of volts, especially on the initial strike, so in testing it is not recommended to take measurements from the output of the igniter, as the input is adequate. If 240 volts are put to the igniter and nothing is happening, usually the best source of action is to try swapping out the igniter. Discharge lamps need 20,000 volts or more to start when they are hot, which is the reason why most of them do not have a hot restrike. You cannot just restrike them. Once turned off, they must cool down to an efficient level, so the igniter can then reproduce enough voltage. Some lamps can be restarted immediately if the lighter can provide enough voltage, but be advised this can shorten the lifespan of the lamp. This concludes this video, and we'll see you in the next one.